Thank you for tuning in to Iowa State's annual 3-Minute Thesis competition. 3-Minute Thesis was founded at the University of Queensland, and it challenges graduate students to present their research to a non-specialist audience in 3 minutes or less. This year, our competition is entirely virtual. 7 outstanding finalists were selected from our preliminary rounds, and a panel of 3 judges will choose a winner and a runner-up from these 7. As an audience member, you can help us select a People's Choice Award recipient. After you've watched all the presentations, click on the link in this video's description to vote. The winner, runner-up, and People's Choice Award recipient will all be announced on January 25th.
In the agricultural industry, self-propelled sprayers are technologically advanced ag machines, which are used to automatically apply chemical products for crop production throughout the growing season. Now, these machines are really important for the field of precision agriculture in terms of providing precise chemical application for maximized crop yields. At the end of the day, these machines need to be as efficient and as effective as possible for a sometimes relatively narrow spray season. Some of the useful ways to increase the productivity of a sprayer are to use wider booms and travel at faster machine speeds. However, the utilization of wider booms and faster speeds introduce boom height instability challenges, especially over high impact terrain disturbances, as shown in this visual, where the machine is trying to cross a terrace. When these booms become unstable, certain ramifications ensue. These ramifications include uneven chemical application, which alludes to the principle of whether one is of over applying versus under applying chemical, and starving the crop of its needed nutrients. Another ramification includes crop and boom damage. When these booms become unstable, there's actually a possibility for the booms to strike the crop and or the ground with enough force to cause damage to the crop and the boom structure itself. Last but not least, the most important ramification is spray drift. Now, when these booms are too far away from the crop canopy, where there's significant boom height error, as shown in the visual above, there's potential for the chemical to drift throughout the air into neighboring fields and water systems, like rivers and lakes. Now, drift from dicamba, which is a popular pesticide, damaged nearly 5 million acres of soybeans in the US between 2017 and 2018. To reduce these ramifications, this is where the importance of my research comes into play. Previous research are really focused on the boom system itself, where hydraulic capabilities and software control strategies have been improved. However, my research really concentrates on improving boom performance through improvements in the chassis suspension system on the vehicle, where I try to mitigate the effect of terrain disturbances up front on the machine before ever reaching the boom. This is where virtual engineering comes into the picture. In the realm of agricultural machine design, it can take numerous years to even develop, build, and physically test the performance of a prototype chassis suspension system. On the contrary, a dynamic systems model has the power to provide crucial research to expedite feasibility analysis, determine necessary component performance, and quickly iterate simulations to optimize suspension performance. Initial virtual investigations thus far have demonstrated that an optimal adaptive chassis suspension system has the capability to reduce maximum boom height error away from the target height by 36%. Therefore, my dynamic systems modeling sprayer research, which maintains a specific concentration on developing an adaptive chassis suspension system, is critical to helping reduce system disturbances, increase boom height stability, and therefore improve boom height performance.
Around the world, land is constantly being converted from natural habitat to agricultural and urban landscapes. Iowa is an extreme example of this. The maps on the top left show that in the 1800s, Iowa was covered in mostly tallgrass prairie, shown in yellow, which had been converted to agricultural land, shown in gray, by 2009. This land use change is known to harm many organisms, including those that can utilize these agricultural landscapes, such as bees. However, there are federal programs that help fund farmers to take land out of production and establish native habitat in order to improve environmental health and native organism populations. I investigated plant bee communities in one of these conservation programs known as Prairie Strips, which establishes small channels of native prairie plant communities within row crop fields, shown in the top right image. Previous research found higher native bee abundance and richness in crop fields with prairie strips than crop fields without natural habitat features. However, because bees are intricately linked to the plant species that they visit, it is crucial to understand how this affects plant-bee relationships in order to meet conservation goals. Using this novel approach, I investigated how plant-bee interactions affect ecosystem function and native bee health in crop fields without natural habitat features and crop fields with prairie strips, and I found three main results. First, prairie strips allowed bees to find food resources more easily, reducing stress, causing wear on their wings, and allowing them to obtain more balanced nutrition while visiting a similar number of plant species. Second, prairie strips had more plant species shown to interact with at least one bee species, increasing their chance for bee-mediated pollination. Third, prairie strips showed a well-established structure of abundant species interacting with rare species, which increases conservation support for rare bee species. These three main findings support the idea that native bee biodiversity conservation can simultaneously exist within highly agricultural landscapes such as Iowa, which are likely to become more common as the human population continues to increase. Future work could investigate differences between these natural habitat features in order to maximize beneficial ecological interactions and improve conservation support.
Variability exists everywhere. If we were able to do this live, we can just take a look around us and see that variability exists among us humans as well. We will see people of different height, different weight, different skin color, and this is great. However, variability is not always a good thing in all environments. Take a car, for example. A car is made up of thousands of parts. All those parts have to work together to create a car that is safe. If you have a few defective pieces in your car, this could lead to an accident, and people could lose their lives. This leads me to my research. I am looking at manufacturing variability. To do this, I have to look at 4 factors that are associated with manufacturing variability. These factors are equipment, process, material, as well as the human aspect. Let's look at one example. Let's look at the human aspect. The human operator is used to identify defective pieces. They typically take a look at a part and say this is a defective part, let's not use it in production. Now imagine that same human at 5 p.m. A human at 5 p.m. is really tired and probably will not be as sharp as he was in the beginning of the day. And so the human with this at a later time with added fatigue could miss a few defective pieces and let it go into production, causing a couple of accidents. Now let's look at a different example. Human A and human B. Human A who's worked there for 5 days, human B that's worked there for 10 years. Human B who's worked there longer should be able to do a better job at finding defective parts just because he or she is more experienced. Well, looking at these factors, how do we determine how do we quantify human A and human B? How much better is human B? This is hard to do. It's really difficult to quantify something that is subjective. And so my goal with my research is to identify and quantify these factors that lead to variability in finding defective pieces. And then ultimately I want to reduce the variability due to these factors so that we can reduce the amount of defective parts going into production, hence reducing catastrophic failures. My ultimate goal is to not just reduce variability in finding defective pieces, but reduced variability in all of the manufacturing processes. Thank you.
Do you know that in a few years you won't be able to get a better smartphone? Actually, everything we call electronics, from computers to bypass switches, is built using transistors. Transistors are built smaller and smaller, and now they are the size of only a few hundreds of atoms. And they cannot be built much smaller than that, so they are reaching their fundamental limits. My research is focused on finding new ways to manipulate information using even smaller objects in prospective magnetic materials. Take, for example, a sheet fridge magnet. Cannot get simpler than that, right? Well, if a fridge magnet was a simple magnet with north and south pole, it would be sticky on its both sides. But it's not. And you can remove the front plastic and this side still wouldn't be magnetic. But the sheet fridge magnet is engineered from simple bar-like magnets with north and south poles, just like from small magnetic Lego blocks, where narrow points to the North Pole. Arranging those blocks, as in the left figure, the magnetic fields add up on one side and cancel out on the other side, giving exactly the behavior of a fridge magnet. Now, in my research, we zoom in to the atomic level. Here, each atom carries a tiny magnetic moment behaving like a bar-like magnet. Now, with atoms, you cannot usually play like with the Lego blocks, arranging them one by one, because in the blueberry-sized chunk of any material, there are more atoms than there are droplets of water in all the oceans on Earth. So, to engineer something magnetically interesting on atomic level, we start from some magnetic material like the one we recently studied, manganese bismuth telluride, in which we found atoms were stacked kind of similarly like the magnetic blocks in the fridge magnet, shown in the middle figures, with the atoms represented as arrows in spiraling strips, blue and red denoting north and south pole. Now, once I model the material, I can play with it. I can stretch it or compress it, I can put it under various electric or magnetic fields. I can even think of a similar material where all atoms of type A are replaced with some atoms of type B. And all these factors I mentioned can change the magnetic properties of the material, and I can see what kind of fun magnetic phenomena I can get. In this specific material, I found a completely new magnetic phase with nicely stacked magnetic vortices, shown in the figure on the right. And this phase no one else has found yet, so it's not only cool, but it's prospective, as I said in the beginning, because if these vortices could be manipulated, they could be used for storing and processing information in the devices of future.
In my opinion, modernization and progression is not really possible through a human versus nature scenario. In fact, I like to believe that every development made in the human race is by learning something new from the nature, about the nature, by getting inspired from the amazing work of nature, or by replicating elements of nature. And this is biomimicry. Biomimicry is the process of developing products that are inspired by nature or imitating elements of nature for various applications. Several biomimic products exist around us, right from the aeroplane and wind turbines, which have been inspired by flying birds and dragonflies, to Velcro, which has been inspired by dog fur. One such biomimicry is shark skin biomimicry. Now you would think, why shark skin biomimicry? This is because most of the shark species have a unique scale texture on their skin surface. This scale texture allows shark to swim faster and more easily in water by reducing the drag and increasing speed. This same scale texture provides antimicrobial property and thus prevent bacterial growth on the surface of shark skin. Several research have focused on the drag reduction aspect of shark skin biomimicry, while some have developed texture getting inspired but not by replicating the shark skin for antimicrobial purpose. So I identified a research gap in terms of replicating the shark skin texture and analyzing the mechanical and antimicrobial properties for functional textile application such as gloves, masks, and many more medical textiles. By using the very innovative yet relatively new manufacturing technique of 3D printing, I developed fabric swatches with texture similar to the shark skin scaled effect. After characterization of the texture in terms of morphological analysis, I could prove that the texture is similar to the texture present on shark skin. While the mechanical and antimicrobial analysis exhibited reduced bacterial growth and thus exhibit potential application as a non-toxic antimicrobial material. From this pandemic, we all now realize the importance of effective and non-toxic antimicrobial textile fabrics. And so I would like to believe and hope that my research will lay a foundation for exploring shark skin biomimicry by replicating its texture and exploring its application as a non-toxic antimicrobial material. Thank you.
How many of you wear a helmet? If you wear a helmet, then you probably know how hot and uncomfortable it gets on your head due to lack of air circulation. Did you know about 40 to 50% of total heat that is produced in our body is released through our head? Wearing a helmet restricts the heat exchange from head with the outside air. This is even worse for football players who have to wear a helmet and have to play in hot and humid weather conditions. It creates an uncomfortable and dangerously hot environment to the head of the players, and it causes deadening of their senses and decrease in their ability to concentrate on the game. As you see from the top right corner of the slide, there have been a lot of heat-related deaths in football. My research focuses on keeping the football helmets cooler, thereby providing comfortable head temperature for football players. How am I going to achieve it? I am going to use a special type of cooling material attached to the interior of the helmet. It works by changing its phase from solid to liquid or liquid to solid while providing useful cooling by absorbing the heat energy from our head. It is a powder-like material. It is enclosed in a thin flexible copper pouch. I am using copper pouch because it acts as a good thermal path in conducting the heat from the head. I am also using an aluminium honeycomb inside the pouch, which will help to further enhance the heat absorption. This entire assembly is attached to the interior of the helmet using a Velcro tape so that it can be easily attached and removed from the helmet. You could see the helmet design from our slide. This pouch sits inside the helmet without affecting the safety design of our helmet. And as you see from our slide, the projected results show that a normal helmet takes about just 8 minutes to reach 40 degrees Celsius, which is shown in gray line. Whereas our cooling helmet takes about 90 minutes to reach same 40 degrees Celsius, which is shown in orange color line. Which means this cooling helmet can keep the helmet cooler for more than 1 hour. Therefore, my research helps in preventing heat-related deaths and illnesses, and it provides comfortable head temperature for football players.
According to the World Cancer Research Fund International, there were 18 million cases of cancer worldwide in 2018, and this number is only predicted to rise. The United States has the fifth highest number of new cases, with about 1 in every 250 people diagnosed. The impact is severe. How many of you know a loved one who has battled cancer? Thousands of people every day lose someone to cancer, and despite tremendous effort, there is still not reliable treatment, much less a cure for the vast majority of cancers. This is why it's extremely important to dive deep into the cellular and molecular mechanisms that drive its development. At every stage in our lives, our cells are dividing, from the ones in our hair and nails and our skin as well. Even as adults, our bodies require over 2 trillion cell divisions per day to remain healthy. Each of these divisions are a highly regulated and irreversible process that must ensure that our DNA is correctly divided. If this process goes wrong, it can lead to an unregulated growth that will then manifest as a tumor. So, during cell division, the DNA molecules get attached to these rope like structures called microtubules. These microtubules play an essential role in pulling the DNA apart so that it's equally segregated into the two newly divided cells. And a critical part of making sure this happens without any flaws are the cellular checkpoints and error correction machineries that monitor this process at every stage. The checkpoint stops the cell cycle from progressing with missegregated DNA, while the error correction machineries resolve the inaccuracies. Unfortunately, if these mechanisms ever fail, missegregation of the DNA will occur with potentially devastating consequences. My thesis work is focused on understanding how the checkpoint and error correction machinery allows our cells to properly attach the rope like microtubules to the DNA with such amazing accuracy. When it works correctly 2 trillion times, it grants us another day of life with the ones we love. I'm working hard every day because I know my thesis will help build a clear understanding of how the cell's checkpoint and error correction machinery work, and that such knowledge will provide a groundbreaking platform for the development of novel and more powerful therapies to treat and cure cancer when it occurs. Thank you.